Hello. Today we are going to continue working with systems of equations, but today we're going to be looking at applications of systems. As a reminder, we have three methods for solving a system of linear equations. One is graphing, one is substitution, and one is elimination. As we're solving applications, we will only use substitution or elimination. We will not be using the graphing method. Let's go ahead and take a look at the first problem. Now, on your notes page, you already have this problem written out, so you don't have to write everything down. Just make sure you have that out with a highlighter or a pen or pencil. Let's read through it first. And as we're reading through it, let's highlight the most important information. Aaron sold 1,500 tickets for Battle of the Bands. 1,500 tickets, that seems pretty important. Student tickets cost $4 and adult tickets cost $5. So student tickets cost $4 and adult tickets cost $5. I'm going to mark an arrow there. This is a little more difficult to do, but I'm going to mark that as well. So I know that student tickets are $4 and adult tickets are $5. I know that Aaron's sales totaled $6,350. Unfortunately, the person taking the tickets threw the tickets away. We're supposed to determine how many adult tickets and how many student tickets did, I think that's supposed to say Aaron sell. Did Aaron sell? Okay. Well, as I'm reading this, one thing I noticed is that part of the information has to do with the cost of the tickets, and the other information just has to do with the total number of tickets. So I'm going to go ahead and define variables. I know exactly how to define the variables because I need to answer the question that's asked, how many adult tickets? So I am going to let A equal the number of adult tickets that were sold, and I am going to let S be the number of student tickets. If you feel more comfortable using X's and Y's, then definitely use X's and Y's instead of two different variables. Okay, so I have two equations that I need to write because I know that a system is at least two equations. So I know the total sold, total number sold, but I also know the price. So as I'm thinking about my two equations, I do know that the total number of tickets sold was 1,500. So I know that the number of adult tickets plus the number of student tickets must equal the total number of tickets that was sold, which is 1,500. But I also know information about how much each type of ticket cost and the total cost. So my second equation, I know that the student tickets were $4 and the adult tickets were $5. So $5 for every adult ticket sold plus $4 for every student ticket sold, and the total sales was $6,350. So at this point, if you don't have a calculator out, go ahead and get out a calculator. And as I compare my equations and try to determine whether I should be using substitution or elimination, the very first thing that I'm going to look at, okay, is the form of both equations. Both of these equations are in standard form. They are set up perfectly for elimination. Okay. perfectly for elimination. So that's the method that I'm going to choose. But what I have to do is take a look at the coefficients of A. Okay, I do not have opposites. I have a 1A and a 5A. I also have a 1S and a 4S. I'm always going to try to use the smallest number possible when I multiply. So, knowing that, I am going to stick with the S's, the number of student tickets sold, and I'm going to determine what I need to multiply by. I recognize that if I multiply the first equation by -4, then that would give me the necessary coefficient, the needed coefficient for S. So I'm multiplying both sides of the first equation by -4. That's going to give me -4A minus 4S equals 1,500 times -4 is -6,000. The second equation, 5A plus 4S equals 6,350. Okay. Now, because I do have opposite coefficients, -4S and +4S, when I combine the two equations by adding them, the S's will be eliminated. So I just need to finish the rest of the addition. -4A plus 5A is A, or 1A. -6,000 plus 6,350 is 350. So what I know is that I have sold 350 adult tickets. Okay. So because I have a lot of information about the tickets sold, I'm going to go back to my original equations, and here they are. Here's the first one. Here's the second one. The first one is a simpler equation to work with. A plus S equals 1,500. So I am going to use that equation. I know that the number of adult tickets plus the number of student tickets is 1,500. And I know that there were 350 adult tickets sold. So, to solve for S, the only thing that I need to do is subtract 350. 1,500 minus 350 is 1,150. That is what S, and that is the value of S, and that represents the number of student tickets sold. Okay, so as I'm writing my answer is how many adult tickets were sold and how many student tickets were sold. So because it's an application, I don't just want to write my solution as a word pair. I actually want to specify what each of the values represent. Okay, let's go ahead and take a look at a second example. The second example, suppose you have just enough money in coins to pay for a drink and snack at Quick Trip totaling $3.25. Okay, you have 16 coins, all quarters and dimes. Find the number of each type of coin. Okay, again, let's go ahead and either highlight or underline the most important information. Okay, all right, I know that I've spent $3.25. I have 16 coins, that's important. Okay, what is it that we are supposed to find? Is it how many drinks and how many snacks? Not always, but most of the time you can find what the question is asking for in the very last sentence. Find the number of each type of coin. Well, that makes me think I need to figure out which type of coins are we asking for. All quarters and dimes. So I am supposed to find the number, not the value. We already know the value of quarters and dimes. So I'm going to set up my variables and define my variables. I'm going to let Q represent the number of quarters that I have, and I am going to let T represent the number of dimes that I have. Okay. All right. So now I'm going to go ahead and set up my equations. One thing I notice is that I have 16 coins, and they're all quarters and dimes. So again, we have one that has to do with the value, the one equation that's going to have to do with value, and the other is just with the total number of coins. Okay, so my total number of coins is 16, which means that quarters plus dimes equals 16. And I know the value is $3.25. Well, where does that value come from? Well, the problem doesn't tell me, but I already know that a quarter is 25 cents and that a dime is 10 cents. Okay, I have a system. When I take a look at this system, both equations are in standard form. So again, this is perfectly set up to use elimination. As I take a look at my coefficients, I have a 0.25Q and an understood 1Q. I also have a 0.10D and a 1D. All right, so just like on the first problem, I'm trying to figure out what I could do to multiply by that would be the smallest value. And it will be the second equation. I'm going to multiply the second equation by negative 10 cents, or negative 0.1. And I have to remember that I must multiply each side by that value. So let's continue to work just below these equations. 0.25Q plus 10.10D equals $3.25. The second equation, once I distribute the negative 0.1 or negative 0.10, would be negative 0.10Q minus 0.10D equals, and 16 times 0.1 would be negative 1.60. Negative 160. All right, it is time to use the elimination method. The D's will cancel because they are opposites. 25 minus 10 is 15, so I have 0.15Q equals $3.25 minus $1.60 is equal to $1.65. To solve for the number of quarters, I need to multiply by 0.15. And that gives me 11 quarters. All right, if I go back to my original information, okay, I know that I had 16 coins in all. This first equation, or excuse me, the second equation told me that Q plus D equals 16. So if I have 11 quarters in my pocket, how many dimes do I have? Well, after subtracting 11 from each side, I know that I have 5 dimes. So again, when I write my answer, I'm going to make sure that I have labeled it and I'm very clear about what the numbers represent. I walked into Quick Trip with 11 quarters and 5 dimes. Okay, our last example. Annie is responsible for buying craft supplies for her younger brother's Boy Scout meeting. She must buy 12 glue sticks and 300 wooden craft sticks. Well, that's got to be important. 12 glue sticks, 300 craft sticks. The glue sticks cost 6 times as much as the craft sticks. The glue sticks cost, okay, 6 times as much as the craft sticks. That's going to be important. She spends exactly $74.40. That must be important as well. And did not have to pay any tax. What was the price of each glue stick and each craft stick? Okay, well again, the question, okay, the very last sentence is telling me, is asking me, okay, how to answer the question. So I'm going to set up my variables. So I'm going to let G, okay, equal the price of a glue stick. And I am going to let C represent the price of a craft stick. Okay, all right. Well, I know that I need to buy, or that Annie needs to buy 12 glue sticks and 300 craft sticks. So so let's talk about what I know. I know the price, information about the price of the glue sticks and the amount she spent. But then I also know that in the second sentence that I underlined, the glue sticks cost 6 times as much as the craft sticks. Let's work with the price first. She bought 12 glue sticks. I don't know the price of the glue sticks, but that's what G is representing. Okay. She also bought 300 craft sticks. I don't know the cost of each craft stick, but that's what C is representing. And I do know that Annie spent a total of $74.40. Everything in this equation had to do, okay, with the number bought and the price. Okay, the second piece of information is that the glue sticks cost 6 times as much as the craft sticks. The glue sticks cost, okay, or the glue sticks, the price of the glue sticks is the same as 6 times the price of the craft sticks. Okay, this one is, I think, more difficult to write. The glue sticks, and G represents the price of the glue sticks, cost, which means is, that translates to an equals, 6 times the cost of a craft stick. Okay, so we are going to go ahead and use substitution because these two equations are not in standard form. The nice thing about this is that our second equation is set up perfectly for substitution. Now, when I use substitution, I like to write the equations side by side to help me remember that I do not use the equations at the same time, okay, as we do when we're using elimination. All right, I know that G is equal to 6C, so I am going to place a box around 6C. And that tells me that I'm going to go into the second equation, and I am going to replace G with 6C. So 12 times 6C plus 300C equals 74.40. Okay, all right, and now my equation is in terms of C, and I can multiply everything out. I know that 12 times 6 is 72, so 72C plus 300C equals $74.40. Okay, continuing to solve, 300, I'm going to add my like terms together. 300 plus 72 is 372C equals $74.40. And the last thing that I need to do is divide each side by 372. So $74.40 divided by 372 is 0.2. So it's 0.2. That doesn't really mean anything to me, okay, in terms of money. So I have to recognize, okay, that this is the price of a craft stick. Okay, so that price will be in dollars, and I need to make sure that I use a second decimal place. The cost is 20 cents. Okay, and that is 20 cents per craft stick. Okay, All right, I'm going to go back to my original equations and look at this. I know that the glue stick is 6 times the cost of a craft stick. So the price of a glue stick is 6 times the price of a craft stick, and each craft stick is 20 cents. So 6 times 20, or 0.20, is $1.20. Okay, so the price of every glue stick is $1.20. Okay, so I'm going to make sure that I'm very clear, that I circle my answers, that I have everything labeled, okay, before I finish. Tomorrow in class, you are going to be working on application problems, many which are similar, okay, to the 3 problems that you did tonight. Have a great evening, and I will see you